Hello everybody. So I apologize. I mean, there's just so much to go over in this class, and it really makes me wish we had like an advanced Python class, or maybe even just a class that's devoted only to video game processing. But there's so many different kinds of projects, and I'm trying to help people as best I can. Just everybody's idea is a little bit different, and I actually want it to be that way. I want the project to be something that you personally would like to do instead of something that I'm telling you to do. Okay, so here, one of the things that people asked me about was a Space Invaders game. How can you do that when you have tons and tons of little invader characters? And so here, what we've got is, if you just look at this, some of this should look familiar. We're importing Pygame, defining some colors, setting the size of the screen, and then setting the screen size by creating this tuple that we use later. And then I'm setting my default directory where I have this little image, and I'll go ahead and put this image up with this video on the website. Now, I'm specifying how big this image can be. I'm making it 30 by 30. Otherwise, it's just huge. And then I've got two images here, Invader 1A and Invader 1B. So if I go to my downloads file and go downloads, and go to my invaders folder. I should have an invaders folder here. Oh, that's not, where's my invaders folder? Space, that's what it is. So yeah. So I just made these, I started with ones that somebody else had made, and then just kind of modified them as necessary. But this is Space 1A and Space 1B. Because he sort of walks. I don't know if you guys are familiar with Space Invaders. It's a super old game, but it just alternates between this image, and then back and forth throughout the whole game. For this, I'll just do this to illustrate something at first. So what would we do if we wanted to have more than one invader on the screen? So we've got one invader, and we know how to make things move around the screen. We would just change the X dimension if we wanted to move left and right, and we'd change the Y dimension if we'd want it to move up and down. But what if we wanted a couple of these things? And for this, I'm going to say just two. And what I did was I created a list and just called it bug list 1. And that's because in Space Invaders, they kind of come in layers. Like this is the top layer, and then there's 2 layers of these, and then 2 layers of these at the bottom. But bug list 1 is a list of bugs in the row. So I'm just doing 2, or I could do 3. It's not really harder to do 3. Let me do 4. So what I'm saying is that there are 4 numerical values in this bug list, and the idea is that if there's a 1 here, that means that we will paint the bug into the picture. Now, if there is a 0 in here, we would programmatically change the value to a 0 if the bug gets blown up, and then we no longer paint that bug, and then he no longer exists. So, but we're going to say that there's going to be 4 bugs. 1, 2, 3, 4. And so when we draw them, here I'm just doing just blitting this one bug onto the screen. Now I could do another bug by just screen blitting another bug this way, and just saying instead of player 1x be player 1x plus, I don't know, 50 or something like that, right? So then if I go ahead and run it, then now I've got 2 Space Invaders on there, and so on. And I could just keep doing this. Make this one maybe add 50 or add 100 to it. And then add another 50 to it. So this way we could draw 4 different bugs on the screen. So I'm going to run it. And there we go. So now we got 4 bugs, right? But we've got duplicated code. And whenever you see code that's just copied with maybe slight differences, and especially if the differences can be calculated, then it's not a good idea to just keep putting basically the same line of code multiple times in your program. It just causes problems. It takes up more space, and it's harder to maintain, and just not a good idea overall. So what we really want to do here is create a loop. And so let me go ahead and see here. So this thing kind of, it's sort of would be our anchor point. Now, P1X and P1Y, that's right here, right? Upper left corner, because remember, Y goes backwards. It starts at 0, and then the numbers increase, and then x starts at 0 here, and the numbers increase going this way. All right, so this is P1XY. Those are those coordinates. So how can I do this in a loop? Well, what I can do is I've got a list, so I can do a for loop for bug in bug list 1. Right? And so now bug is going to act as kind of an index for me here. So what I can do is say for every bug in bug list 1, we want to do this. Now, what I want to do though is add things to P1X every time I go through the loop. I'm going to say plus something, right? So maybe we'll define what something is right here first. Okay, everybody with me? So what I really want is some kind of numerical value. So I'm going to change this a little bit. I'm going to say for bug in range, because I want bug to be a number. I want it to be a variable that changes. Otherwise, I'll have to set up another counter, some type of other accumulator. But we can use the whatever this is in the for loop if we specify a range. So we know it's going to be 1 and then 5, right? So remember with the range, the second number, when we're doing the for loop with a range, the second number x is a barrier, right? So it'll do 1, 2, 3, 4. As soon as it hits 5, it goes, okay, time to stop. So it'll never reach 5, but I've got 4 things in the bug list. Okay. So now I should have a numeric, like bug is going to be a number. The first time it runs through the loop, bug will be equal to 1. So how can we use that programmatically to calculate how these bugs are going to show up? So the first time I run this, I really just want this bug to show up in position XY. So I really don't want to add anything to P1X for the X value. Right now the P1Y will be fine. I don't want that to change. So the first time I really just want it to be P1X plus nothing. So I'm going to say bug minus 1. What is bug minus 1 the first time I run through? It'll be 0, right? Times. And then how far over should we put this? Let's put a spacer. So I'm going to put maybe, we'll see if it'll work here. I think I might have to put it inside the loop, but let's try. Let's put bug space equals, I don't know, those things are 30, so call it 50 maybe, times bug space. Okay, so live without a net here. I don't know necessarily that this is going to work, but we will know soon, won't we? It does not like the syntax. Bug space. Okay, and bug space. Oh, I have bus space. Have mercy, I've been waiting for the bus all day. All right, so let me kill this and let's see. Will this actually create bugs the way I want it to? No, it didn't. Looks like it smushed bugs all together. And it looks like it kind of offset them a little bit. So bug space, maybe bug space is not enough. Plus bug 1 times bug space. It's position 1 plus bug times bug space. Bug minus 1 times bug space. So, oh, the minus 1 happened. Order of operations got me. I think that's what happened. Let's try it again. There we go. Isn't that pretty? So yeah, what happened was order operations meant the multiplication happened before the subtraction. So all right, so now I've got 4 bugs. So this is a way that you can use very little code. And remember that Python is very functionality dense for very few statements. But I mean, this is not a lot of code to write to paint all these bugs up here. Now, once you've got them, what do? Well, in Space Invaders, they move left to right. Right. And now, just like when we were dealing with boundaries and collisions with other things, for us to know what's going on here, we're going to have to know what the last bug is, right? So what we need to know now is we need to know the minimum bug min. We'll say that's equal to screen wide. So I'm setting the minimum over here, and then I'll set the maximum over here, and then we'll change them programmatically. Equals 0. So how can we find out what the min and the max are? And the idea is, like, let's say this thing gets turned to a 0. Then we wouldn't want to paint this guy. Oh, well, we didn't put that logic in here either, did we? So let's say if a bug list, and then for the bug equals 1, that's the only time we'll screen blit this guy, right? So if there's not a 1 here, then you won't paint him. So and a double equal, right? Okay, so now, well, it still doesn't like it. What's it doing? Bug list 1. Okay, it's bug list 1. All right, so let me see if that worked, because it, I mean, I think it did. Oh, look, nothing. Okay, so something went really wrong here. If bug list bug equals 1. Let's see, well, let's print bug list. Let's print this guy and find out. Python is not responding. All right, so, whoops. I don't want, report your own issues. I got Space Invaders to program. Okay, so here we go. Let's print this. And also, I want to print bug, just so I know what is going on here. You know, you can think that you know what's going on, but sometimes trust but verify, right? Okay, so there we go. And nothing's happening in here. It's just not, it ain't doing nothing. That's right, Ludwig, it's not doing nothing, is it? So let's run it again and see. I'm going to stop the code. I know, Ludwig, it's terrible. So, all right, this code isn't working for some reason. Let me get rid of the if statement. We'll blit it anyway. But I want to see what those values are. So we're no longer doing it to see if we're going to put the bug out there. I just want to see what the values are. Because I thought I knew, but maybe I don't. There's just so many things, and I don't know. Looks like I'm going to have to restart my spider session, so I'll be right back. Okay, I think I know what it is. So here, when we're indexing in the list, it starts with 0, so we need bug minus 1, right? So as an index that starts with 0, even though our range is 1 to 5. In fact, I don't know, man, maybe we should make our range 0 to 4, because it seems like we're doing a lot of minus 1 stuff here, but let me just run it and see if that fixes it. Okay, there we go. So we got it, and that's working. So let me kill that. Now I want to. Okay, so it's doing 1, 2, 3, 4. Now notice it's painting that screen in the clock tick time. So it's painting it 60 times every second. That's okay. It doesn't. You don't have to move them every time. You can change this clock tick. This is a really old game. It did not have the refresh rates of modern games. So you can experiment with that. I mean, it's up to you. But now, here's the thing. This bug list should say, give me the first 3 bugs, but not the 4th one. So this is where, let me try that if statement again. So if, well, I don't even remember what it was. If bug list bug if this is equal to 1, right? Wasn't that what we did? And let me tab this over. All right, so I think this will work, but then I always think this stuff will work. Let's run it and find out. All right, there we go. So we got 1, 2, 3, 3 bugs. Just 3 bugs. And let me stop this. Let's stop our execution. And what if it were something else, like maybe like we shot one that was in the middle? And I'm not advocating for violence. Maybe this is something where we shoot them full of love and they're no longer tormented and trying to descend down to the earth. So I don't know when this is going to stop. Let's close that program. So all these things that are happening to you happen to me. It's just, you're probably not that much worse at coding Python than I am. All right, so away we go. And oh, it didn't like it. So I think I got another one of those errors where I'm going to have to reset Python. So let me reset. Okay, so we're back. What I'm trying to do here is print the bug list. Hold on, my dog just rang his bell. Okay, so we're back. We'll run it again. So there we go. So we've got 3 aliens because it's 1, 0, 1, 1. Now, we're going to have to handle all that stuff programmatically, but you guys see what we're doing here. We're setting up basically like a key that lets us know whether we're going to draw the bug or not. And so now what happens if we blow a bug up? Well, we would programmatically say we'd go to the index and go to bug list and then give the index. Like if we blew up this first guy, we'd have bug list index 1 and then equals 0, right? And then from then on, it wouldn't put it on the screen. So next thing you'd want to do probably is to make these things move, because they're not that interesting if they just sit there stationary. And you know what? I am going to slow down our clock tick. Let's make it, I don't know, we'll make it half normal speed. Be a little easier on our processor. Okay, so let's get rid of those print statements. And like, man, there's a lot of functionality going on just for this much code. All right. So we're going to make the bug move, right? So P1X is the X coordinate of where it starts to get drawn. So after we draw it, we want to do something with the X coordinate, right? So let's say P1X plus equal, I don't know, what, 5 maybe? Because these things moved in a sort of jerky fashion. So, and this has to get tabbed over. Whoa, not that far. Okay, so, and we're in this loop. Now I got to come over right there. All right. And then this is, this goes here too. I don't know how I got scooted. All right, so let's run it and see what happens when, okay, they're running, but I'm not, oh. So we need to set the screen to black. So we'll do screen fill black here right before we do the display flip. Oh no, we need to do it, actually, we need to do it before we blit, right? Because otherwise we'll blit it and then cover it up with darkness. Okay, let's see if this makes aliens that move. Okay, so they're moving pretty fast. Like, they move that fast at the end of the game. Oh, they just went like right off the edge of the earth. But in Space Invaders, it was more like blip, 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 right? So we don't want to make them move every cycle. So let's set up a counter here. This is just like a timing loop that we're going to do. So we'll say count equals 0. And then down here we'll say if count greater than or equal to 5. Actually, we call this count limit, kind of like count chocula. Okay, so count limit, let me put it up here. We'll say count limit equals 5. Because to make a move faster, we can change count limit programmatically. All right, so we'll say count equals 0. We'll do that before we hit the loop. And we'll say if count is greater than count list. All right, so what did we do? Whoops, not 2, 1. What did we do here? Well, what we're saying is count starts at 0, and the first time it goes through the loop, these invaders are not going to move. Our increase of P1x is only going to happen after count is greater than the count limit, and the count limit's 5. Let's run it and see if it... Okay, so like blip, 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 blip. So let's increase that count limit to 10. It shouldn't move half as quickly. That's getting closer. That's starting to look a little bit, but it's still fast for the start of the Space Invaders screen. Oh, let's make it 20. We'll see. Yeah, that's probably pretty good. Okay, now, here's the other thing. Is remember when I said there's 2 images here? So every time they moved in Space Invaders, their appearance changed. So we're only blitting Space 1A, but we was clever. We used some strategery here. We called it bug 1 up here. Bug 1 is bug image 1A. So in here, when we hit that count limit and they're ready to move, we're going to change the bug image. So if bug 1 equals bug image 1A, then we'll set it to bug image 1B. Else, we'll set it back to 1A. I think this will work, but as always, my disclaimer is I always think it'll work. All right, so let's run it and see what's going on. There we go. Oh no, it went to 1B and it never changed back. So that ain't no good. Why would you do that? So if bug image, if it's equal to bug image 1A, then it changes to 1B. Otherwise, oh, it should. Well, let me do it as a separate. Why would I need a separate if statement instead of? Oh, I never set it back to A. That's what it is. Okay, let's run it. Oh, that is looking very Space Invader-y. Maybe they need to move further though. So as you do this, you just have to sort of, it's like cooking. You gotta season it for taste. So bug space, like let's see here, count. Where did we increase 1? Oh, plus equal. Okay, so this will be the amount moved. So we'll call this P1x amount. There we go. So, and up here we'll set P1x amount. And what was it, 5? So let's make it 10. So they move a little bit more every time they move. That's pretty Space Invader-y. I mean, let me see if I can pull up a video of what the original game looked like. Okay, so this is why my generation's pretty warped. This was Space Invaders in the 70s. So, and you can see the hardware is so... the processing power. Well, let me mute this. That's really obnoxious. So the processing power is like it couldn't update them all at once, and you can see it like it ripples. I mean, we could emulate that programmatically by making a little delay in it. But yeah, I mean, this was done with silicon chips from the 70s, so they weren't very powerful. So it took a lot of programming. I mean, it was a funny thing. Like, the people who had to work with the worst hardware had to be the really good programmers. So, all right, so it's like bloom, 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 and it's moving along. All right, so enough of that. And let's run it again. Let's see if this, I think, yep, bloom, bloom. Well, that's a little fast maybe even. So let's slow it down a little bit more. And it speeds up as the thing goes on. But count limit, so instead of 20, let's make it 25 maybe. Yeah, that's about right. So, you have to do this for for taste. But yeah, so we're just alternating between the A and the B image. Every time we move, we switch to the other image. All right, now you'll notice that if we just let this run long enough, it's going to run right off the edge of the screen. So, but the thing is, how do we know when to make it bounce? Because this guy could blow up and then he wouldn't be there. We'd have to make it when this guy is there, right? So I think we just need to do some matheration here and get to where we know what the last one is. So how could we do that? I think what we need to do is probably, so here we're count, let's see here. Yeah, so this, usually right after we make it move, like either before or after we make it move, we would test to see if it blows up. So really we don't want to do all this every time. We only want to do it when the players are moving, right? So here's the thing. I probably want a loop, really. So let's say, for instance, our bug list. I'm going to get rid of some extra spaces, even though spaces lead to good readability, but I want to look at all this stuff at once. So, like, if our bug list were this, then this would be the rightmost bug. Okay, so, but it could be, it could be like this and this and this, and then this is the rightmost bug. So what I need to do is a loop, probably starting at the right and then seeing if there's a bug, and then going until we're sure that there's not, until we hit a bug. So like we'll start with this one, and if it's a bug, then we'll stop the loop. So this would be a do until or a do while. So let's see. Trying to remember the syntax for a Python do while loop. All right, so let me try this. I'm again doing this without a net, but let's say while. We'll say while no bug. All right, so what is that? We're gonna have a variable called no bug, and we'll set it equal to false. Or we'll set it equal to true. Working with a negative, double negative here. All right, so it's true that there's no bug. This is probably not a great idea. I confuse myself. But okay, so while there is no bug, that's what I'm trying to say here. So while there is no bug, what are we going to do? Well, let's look at bug list. And then we'll do a bug list. Well, we really want 4. But let's set another variable called bug list index, because I don't think we can use this. No, we really don't want to do that. Well, no, we can do it. We should probably do it up in here. Ah, there we go. All right, so we're trying to figure out what the furthest right point is. What I mean there is, like, look at these guys. Right, so there they are. Let me stop the code and see if those will stay up. So I want to find out what that is, or if he's gone, what that is. So what we can do here is, as it's painting these things, then we will kind of keep we'll keep track of it. So here we know what py is, and then when we blit this bug, we put the image of bug 1. Yeah, okay, and then he's at p1x plus bug 1 times bug space. So let's create a variable for that. We'll call this bugx equals, because we're going to do a couple of things with this. And bugx. Okay, so why don't you like that? Screen blit. Bug 1, bugx, and then p1y. Oh, a few too many of these guys. Is that it? No, still don't like it, huh? It's the image. I'm giving you the x and the y. It's probably this. When you get a syntax error, look at the line above. Sometimes it's because you have a quotation mark that's not closed off or a closed paren that didn't close off. Okay, so we've got bugx now. To figure out what this is, bugx is putting it right here. Like that's, bugx is up in the upper right corner of this, so we need to add the width of this. So we'll say bugx right equals bugx plus, and we have a variable for how wide this guy is, right? P1 wide. So this should be the coordinate over here, right? It's the x coordinate plus the width of the character. So that's our bugx right, and what we want to know is what is the maximum bugx right? All right. So, and we did bug max, right? Did we do bug min? All right, so bug max, I guess we called it bug max. So bug max, so we need an if bugx right is greater than bug max, then bug max equals bugx right. What are we doing there? So we're saying that, like right now it starts and bug max is set to 0. We're saying, is this thing greater than 0? Yeah, it is. Okay, well, let's store this value. This is the max x value. And then when the max x value hits this, then we know it's time to bounce off that side. So, in theory, all right. So now we've got this. We did this. We increased P1x. Okay, so now, and we still are going to know what bug max is. So now let's set up the bounce here. If bug max is equal to, we'll say greater than or equal to, because we may have a unusual number of spaces if they move and it might not land exactly on there. But if it's greater than or equal to the screen wide, okay, then we know it's time to bounce them around. How do we bounce them around? Well, we stop moving them a positive amount, we start moving them a negative amount. So what I'm going to say here is, well, P1x amount, can I just multiply that times -1? Yeah, I'll do it. All right, so boy, does it not like that. P1x amount, what was it? P1, oh, it's got in a capital A. Ooh. All right, let's run it. This, I mean, in theory, this could work. Let me clear my variables. All right, let's try running it again. Oh, it doesn't like that destination position for the blit. Where's my blit? Oh, there we go. It doesn't like that? Why don't you like that? Yeah, definitely line 51, so it doesn't like bugx. But it worked when I had that as the coordinate. Let me just paste it in there. Maybe it, I don't know, why don't you like that? Okay, very difficult. Now, wasn't it just that? Seriously. Plus bugx times bug space. I do not know. And now it ain't working, but okay. So that's where I'm going to call it quits for now. But you guys get the idea. Thought I had it there. But you get the idea how to create multiple ones, and then you need to figure out what that is. And then that's when you see when that thing hits the wall, but you only want to update that right edge, the right edge, if you actually painted a bug there, right? So, where do we do that? Right here. So, I don't know why that wouldn't work. Oh, I have an idea. Let's see. So, if we do P1x amount minus 1. Tough one. Yep. Yep. When I run it, it blows up. I want to see. Nope, and it's not even painting. So that blit just stopped working altogether. I got too fancy for my own good. Let me get rid of some stuff here and get back to where we're just blitting things right onto the screen. Bug 1 times bug space. I thought that was good. Okay, so bug 1 is good. And let me get rid of this just in case that's causing some issues. Bug X. Oh, we'll say this is. We'll get rid of bug right because that was part of what we were trying to do. And that. All right, let's try running it. Still invalid destination for a blit. All right. Well, what if we did P1? Well, but we already went through that. P1Y, so that's good. I'm gonna comment this and then rebuild it because I broke it somehow. And you guys would have the advantage of going back through the video, but I don't because I'm making the video. All right, so we'll just say P1X, and then we'll just logic our way through it again. It still says invalid destination, so I don't know what's going on there. Hold on. Okay, here's what it is. The X and Y need to be a tuple. So, all right, let's go back. So, so this should be good. I just need that there. And that there. So we've got the tuple set up. And all right, and let's run it and see how it works. In theory, it'll work. Okay, there we go. So we've got this repaired now. All right, so again, what's the idea? When this thing hits this, not when X hits it, we could just do something that works and then refine. So let's go with we'll put the boundary logic here. So if P1X equals screen wide, then P1X amount equals P1X amount times minus 1. So this will give us more of a rough way to do this, but this gets me every time. Only thing I'm multilingual about is computer programming languages. That is really sad. Okay. And these guys are scooting across the screen. That's just going to take forever. So let me make them jam across the screen a little bit faster. We'll make we'll just make the count limit 1. It'll just go super, super fast. All right, so now I didn't set up anything to make it bounce on that side, so they're just going to keep going until they hit alphabet heaven. All right, so let's go here. If P1X equals 0, right? And then do this. And as soon as we see copied code, that is our sign that we doing wrong. So let me grab this guy. Anytime you just see yourself copying the same line of code over and over again, you need to think about why you're doing it and stop, because it's usually evil. All right, and let's run and see what happens here. And they do kind of move this fast toward the end of the game. All right, so it's bouncing off the left the right way, but again, it's not going to bounce off the right side until we figure out what that right thing is. So here, as we're drawing our bugs, that's where again I got scared and deleted my logic. So let's get that logic in there. So we're going to do that with bug max. So if and this is where that's right. This is where I set up this as a variable. And we call this bug x. Right, there we go. And we could, let me try this. This is how I made it explode last time. All right, bug x. All right, let's see here. Oh, so I've got some bad syntax up here. It's probably, again, remember, if you get syntax errors, look at the line above, too. Okay, and now we just got this if just sitting here, because we was typing something. All right, so if bug x is greater than bug max, then bug max equals bug x. And it's P1 plus, we want to add the width, right? So it's P1 wide, right? We want to add the width of the player too, because we want the right side of the player. P1 wide, no underscore. I need consistent naming conventions. I need to write a style manual for this class. Okay, so here we go. I think this will do that. So then what we want to check is instead of P1x being equal to screen wide, we'll say greater than or equal to. The reason is if we change the amount that the bugs move, like let's say this is the end of the screen, what if it goes boom and then boom, it'll never equal the screen. So we say greater than or equal to just in case. So, and then we should say less than or equal to here. Because it could be a negative number. And then here we're going to say, bug max. All right, so let's give it a shot. Okay, so something happened there. All right, so they just got stuck there. It looks like they turned around. And then they started coming back the other way. So, why'd they so it, what I think what happened was it was greater than, and then like P1x amount, maybe. Let's see, P1x amount. Let's set that equal to 1. Exactly, Ludwig. It's so frustrating. So they're, oh my lord, they're going so slowly. But by setting it to 1, the reason I did that is, then we know that it will hit that barrier. What I think it's doing is it's hitting the barrier, reversing, and then it's still over the barrier and it reverses back. So let's find out. No, that ain't it. Okay, so I think we tested the P1x going the other way. So bug max is not working that well. Bug x is, oh. Let's try this. Maybe that. Hold on, let me kill this. Let me make it move faster. Nope, they still vibrate. Close though. They know that when they get here, they got to do something different. I think maybe I have to put this here. What if I put that before we increment? Good thinking, Ludwig. Yeah, that's what we'll try. No, still vibrating, but that's a little better. What's happening is it's hitting it and then it's reversing again right away. Why would it do that? P1 exits not less than 0. Bug max is greater than or equal to screen wide. So what's happening is it's kind of getting stuck over there and then it's reversing. I'll tell you what. I'm going to set this up as two different if statements, and I'll explain why, even though I told you that that was bad. So here's what I'm going to do. Once it hits this thing, I don't want this to flip around until it hits the other wall, right? So I'm going to set a flag here. And I'm going to say bounced equals right, or we'll say left. Okay, so we want to see if that's true and if bounced. All right, so when we do that, it doesn't like that. Oh, it needs an equal. When we do that, now we're going to change the flag. Now, why did I do that? Because when it bounces off of this right boundary, I don't want it to reverse until, I don't want it to reverse using this command until it hits the left boundary. So, I'm going to go ahead and put this here. And then after it hits the left boundary, we'll flip this flag over to left. And now this can happen again. But until then, we just don't want it to. All right. I think this might work. You guys are probably tired of hearing me say that. -1 and bounced equal. Why don't you like that? N of 1 and 1. Okay, so there we go. Too many of them. All right, well, let's give it a shot. There we go. So now it's doing the same thing over on this side. Okay, so we fixed this. So we change that to left, and then that's right. And then this is just going back and forth and like hitting. Oh, I've got two totally. No, that's okay. P1x less than or equal to 0 and bounced equals right. So it'll only happen if it's like this. Let me take them out of the loop for a sec, or out of that if statement. Okay, let's run it. Huh. All right, so what's happening here is because it's moving 10 at a time, it's probably going just over that. But maybe if we did this as an else, or an elif. Then it could only do one or the other. Let's try it. No, I think what's going to happen is going to do this. It's going to hit right, and then now this is primed. But bug max shouldn't be greater than screen wide. Let's see what bug max is. Oh, so bug max is always 810. So when it's going the other way, okay. So when it's going the other way, once it hits 810, it never gets smaller. So so maybe we need to, well, this is when it paints the bugs. Actually, so we don't want to do this at all unless we're moving to the right. So, so we'll add this n bounce equals left. No, that's not it. We need to start making bug max smaller then. Okay, so I think I have an idea here. So bug max is equal to 0 when we start. Let's go here and say that if say if bounced equals left, then bug max is 0. So we'll reset bug max. No, if we did this every time in the loop, oh, maybe we just do that every time. Let's see. But yeah, because we don't test it till down here. Yeah, let's give it a shot. It's crazy enough to work. There we go. All right, so yeah, so you guys see that, I have difficulty with this too. Now, the other thing that happens in Space Invaders is that after it bounces off the wall, the Space Invaders fall down a little bit. So, like, it should drop down. So how can we make that happen? We can make that happen by, we'll say, P1X amount. We need a P1Y amount. Set it equal to 20, maybe. We'll set it equal to 30. Now we'll set it equal to 25. All right, so then what we need to do is here, when we get to here, we're count. Actually, when it bounces, right? So, whoops. We need P1Y. P1Y amount, right? And same thing when it hits the other side. We're going to increase P1Y. All right, let's see if it works. Yeah, that's pretty Space Invader-y. It looks kind of like that. Now I don't, maybe it's not quite that much. Let me go to 20. Because that's like almost the whole thing of the character. Okay, that's still a little too much. We'll go 15. Yeah, that looks about right to me. So the other thing is, as these guys keep going, they start off slow and then they get faster. And I think they get faster when there's fewer Space Invaders. But again, what you would do is programmatically you'd put in a test, and then you would change the threshold for, or you would increase the, where is it? Yeah, the P1X amount. So you just start making this number smaller and smaller. And then, the, or bigger. When did you make it bigger or smaller? I think you'd make it bigger, right? So, or you would change the number of times you go through the loop before it increments here. So like here's count is +1. So you would change the count limit, and you can do it programmatically while the program's running. So, sorry, this was really long, but you get to see the sausage being made. Let me slow this down a little bit. Those guys are really spazzy. Let's count limit was equal to 1, we'll make it 10. I can't remember what we had it initially, but it definitely wasn't 1. It was probably, I don't know, 20 or something. 25, wasn't it 25? And then what you would do when you wanted to speed them up is programmatically you would change the value of count limit. So that's how you do these things. Now, just like we did the math to see where we would position them, that's how you see what the dimensions are for if you hit them with a projectile, right? So like the first one would be from X to X plus player width, right? And then down, the Y dimension would be Y plus, like player 1 Y plus the player height. Or I think it's called P1 tall. So, and that gives you the coordinates of the bottom of this thing. So when a projectile hits, if it matches the coordinates, then they explode. So, hope that helps a little bit. So all you have to do is have one image, and you can just use something like this to recursively draw it as many times as you wanted. So for instance here, we just did it 4 times, but really the way our code is structured, we can just keep making them, right? And I think on the original Space Invaders, maybe they were 12 of them across or something like that. Oh, no, did we hard code a 4 in there somewhere? Yeah, there we go. So what we need is like the length of a list. So probably maybe list length equals len of bug list 1. I think that works. And then, I don't know. Here, let's see if we can make the code explode again. 1 to list length. Would it be list length or list? What did I just, let me undo that. What did I have in there? A 5, so edit, paste. Oh, let's redo. Well, let me redo. I think it's list length plus 1, but we'll know soon when it explodes. Okay, so there we go. We have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yep, there we go. So we have robust code. So now it will, however many things you do here, it'll create a row. So to create a second row, what I would do, you could do some type of 2-dimensional array. I think that gets hard to read. So I would just create a bug list 2 and 3 for the second and third row, bug list 4 and 5, etc. And then specify the characters that you draw in each row. So it's like you would hard code each row kind of. Still go and iterate, but that each row would be separate. I mean, you could do a 2-dimensional array. I think 2-dimensional arrays are confusing to code if you don't do them all the time. So I would separate them out. So there we go. If you're doing a Space Invaders game, all you have to do is a few characters. You don't need to do a bunch. Actually, hold on a second. Let me show you what a second row would look like, because if you can do a second row, you can do more rows than that. Hold on a moment. Okay, so what I've done here is I've pasted in for a few more images, space 2A PNG and space 2B. So if we look at these guys, pull this up. Go to downloads and let me see, space. Yeah, there's 2A and 2B. So now what I would want to do is down here where I blit the first row, one list length. Let me see. Yeah, that's good. I think I'm gonna do list length 1. Nah, list length, like we would just say that the lists are always going to be the same length. Okay, so now we have bug x bug, and then when we blit, where are we blitting? Yeah, we're calling it bug 1. Okay, so just like we have bug 1, let's have a bug 2 list. or bug list 2. And then we set what bug 1 was. Let's set what bug 2 is. Oh, let's try again. See how much time I save by cutting and pasting instead of just typing. All right, being sarcastic there. So bug 2 would be bug 2A, bug image 2A. All right, so now down here, when we swap the image for bug A, we want to do the same thing for bug B, bug 2. So copy, paste this in. And everywhere, I think if I do a control R, yeah, I can do bug 1, bug 2. All right, so in selection. Kind of, okay, so now everywhere where it says bug, I'll say IMG1A, that should work. It should say IMG2A. Oh, I need all these. IMG1B needs to be IMG2B. Okay, so, okay, what else do we need to do? I'm just going to have it bounce at the same time for now. But you'd really have to see if there's anything there, like in each row. So let's see here. Now, where am I doing my blit? Here. So I want to copy this. Here, I'm going to get rid of the, again, you would want to duplicate this max code. What'll happen if we do? We'll try it. So bug list 2. And, yep, bug -1, and we would blit bug 2 this time. I think this works. It's going to be about, well, yeah, it'll be the same. We're going to see if this gives us a bigger max is what it does. So run it. Oh no, put it right over. So here's what we have to do is, it's not P1Y, it's P1Y plus, probably, did we have a space up here? Bug space? Let's try P1Y plus bug space. Maybe that'll work. That's it started off good. P1Y plus bug space. So I don't know why it replaced. Probably. Bug 1 and bug 2. Oh, down here, I'll bet I replaced it with the wrong one. Yeah, so these should all be bug 1. That's what it was. Got replaced with. I included too much real estate in my find and replace. All right, there we go. So they're chucking along. When it hits the sides, it should bounce. When the red guys have their arms up, it's like they get a little dark line across their middle. I think that's just a glitch. But let's see if it bounces. All right, so it's bouncing. Now, here's something I want to try. Is what if these are zeros? In theory, I think we wrote this code in such a way that it will bounce when the last visible Space Invader hits the wall. Let's change our X amount because I'm just not that patient. Let's change it to 20. And the count limit to 10. Yeah, there you go. So there's only 6 visible and it bounced when that happened. Now, let's try something else a little tricky. Let's put 1 here. Let's put none here. Yeah, let's see. There were ways to get weird things like this, like your missile made it through there, but then the guy on top walked into it. So that kind of worked. Yeah, it worked. So we just have to adjust a little bit down here. So like, let me try this and see. Like, so these were all configurations that could happen. Like you could shoot some, you know, and then there'd be that one guy on the end. So he's bouncing a little bit late. So what's going on with the bounce here? We're checking to see if bug max is greater than screen wide. If bug max is greater than screen wide. So we could say screen wide minus, like I'm just putting in a fudge factor here to fine tune it. There's probably a logical reason for why it's doing that. I just don't know what it is. Oh, I know what it is. It's because we're moving them so much at once. Ordinarily, you don't move them. You know, what are we? We're moving them 50 things at a time. So make it like what was? I can't remember what that was. This was, I think, 25. Oh, that was not good. What was this? 50? Oh, that's the space between each character. It's the P1X amount, 20, so we'll make it, what was it, like 10 or something. So yeah, so I'm just going to let this run for a minute and see if my guy, because I think what's happened was he was moving 20, so it's like he moved and then he ended up over here and then he bounced back, so he was good then. So honestly, when I look at this, this is startlingly accurate to the original Space Invaders game. Like I'm actually surprised that that it's this accurate. So let's see when's it gonna hit. All right, there we go. Yeah, so he didn't go over. Yeah, it's because the X amount that we're moving him was too large. All right, that is it. I'm tired. I'm going to bed. If this helped you, I hope this helped you. I'm gonna post. I'll post this code because for your project you still have to. Yeah, Invaders example. For your project, you still have to create the thing at the bottom that's firing up at them. Create projectiles. You don't have to do the ones that they did on the game. Those were sort of interesting. Like it was a missile and it would sort of accelerate as it went up. You don't have to do that. You can just do rectangles like we did with Flatboy when he was dueling evil Flatboy. But this should give you a start. So there's a lot of codes, a lot to absorb at once. Wasn't necessarily that easy for me. So it's a challenge, but I'll give you this code and this should help you along your way. All right, everybody, have a good evening.